This is linear algebra. We're gonna study orthogonal sets. Previous video, we're gonna discuss about inner product, length of vectors, and orthogonality. So what is mean by orthogonal set? What is orthogonal set? Some set of vectors in Rn that put together in one set, that factor is orthogonal each other. That's we're gonna say orthogonal set. You're gonna correct all the vectors from Rn. They are orthogonal. That's we're gonna say orthogonal set. Here is example. So you have three vectors, u1, u2, u3. That's the orthogonal one out. Which meaning is u1 inner product u2 gonna be 0. u1 inner product u3 gonna be 0. u2 inner product u3 gonna be 0, 1 out. That's we're gonna check it. u1 inner product u2 gonna be 4, negative 1. 3 times 0, 2 times 2, negative 4 plus 4 is 0. u1, u2 is orthogonal. u1, u3, 4 times 0, 3 times negative 2, 2 times 3, 0. That's going to be orthogonal. u2, u3 vector, negative 1, 0, 0 times negative 2, 2 times 3, that's going to be 6. This is not 0. So you're going to say u1, u2, u3 is not orthogonal set. Okay, that's where you're gonna find it. Just simply, we're gonna correct all the vectors which are orthogonal each other. Okay, here is another practice. I'm gonna give the three vectors. This is orthogonal set. We have prove it. So how can prove it? Same thing. U1 times U2 inner product. That's gonna be 3, negative 1. 1 times 2. 1 times 1. That's gonna be negative 3 plus 3 equals 0. That's also gonna u1, u3, 3 times negative 1, 1 times negative 4, 1 times 7. That's gonna be 0. That's also gonna u1 inner product, u2 inner product, u3, negative 1, negative 1, 2 times negative 4, plus 1 times 7, that's the 0, so this is orthogonal set. What is this about? Orthogonal set. So this one is, that's gonna be, guys, the theorem is gonna be if U is orthogonal set, this theorem is very powerful. Then S is, you don't have to prove it, S is linearly independent, and S is base for subspace spanned by S. So this theorem guarantee if all set is orthogonal, that's gonna be basis for the subspace spanned by S. What is definition of orthogonal basis? The basis, they should be basis, but also this basis is orthogonal set. That's what we call orthogonal basis. Next theorem is more powerful and easy way find a linear combination. So previous chapters, we have find the linear combination of bases by using the row reduction, okay? But this one is if your basis is orthogonal. That's very easy to find, guys, very easy to find the linear combination of vectors. So when you have a y vector, it's gonna be Rn. This U1, UP is orthogonal basis, guys. Make sure orthogonal basis. Then we don't have go through the row reduction. We're gonna find each C1, C2, CP scalar value gonna be Y inner product UJ, UJ inner product UJ. That's you're gonna find each CJ, each coefficient. Okay, I'm gonna give very specific example is next slide. So here is S is orthogonal basis, orthogonal. This is basis, and this vector is orthogonal. Then how can I find the linear combination of u1, u2, u3? That's gonna be y vector. So previously we using low reduction find it, but you don't have to do that way when you have orthogonal vector is right there, guys. So let's try to this one, guys. So how can calculate? We want to find the y equals c1 u1 vector and c2 u2 vector and c3 u3 vector. So previously you're gonna use raw reduction with augmented metric, but this one is we're gonna using theorem previous we discussed. So C1 gonna be how can find the C1 y U1 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 product. Let's find the C1. So y is U1. So y is 618. U1 is 311. That's the 3 times 6 plus 1 times 1 plus negative 8 times 1. That's going to be numerator. Denominator going to be u1, u1, 3 times 3, 1 times 1 plus 1 times 1. So top going to be 18 plus 1 minus 8. Bottom going to be 9 plus 1 plus 1. That's going to be here is 11 over 11. That's the one. Let's find the C1. What's easier, right? C2 gonna be Y inner product U2, U2 inner product U2. That's do you find the C2. So 6 times negative 1 plus 1 times 2 plus negative 8 times 1. So this one bottom is U2, negative 1. 2 times 2 is 1 times 1. This one is negative 6 plus 2. Negative 8, bottom is 1 plus 4 plus 1. So you have this one is going to be negative 12 over 6. That's negative 2. Third one is a C3. Y times U3. U3 in a product. That's going to be here. 6 times negative 1. 1 times negative 8. Negative 8 times 7. Here is negative 1, negative 4, negative 4. 7 times 7. That's equal. Here is negative 6, negative 4, negative 56. This is 1 plus 16 plus 49. This one is gonna be negative 66. Bottom gonna be 66. Right? So this is negative 1. Right? So what do you have? Y vector is right there. Now your linear combination is a C1 is 1, U1 vector. C2 gonna be negative 2, U2 vector. C3 gonna be negative U3 vector. That's you're gonna find the linear combination. Guys, much easier, huh? Okay, now let's practice how can find the linear combination of u1, u2, u3 vector when you given a y vector. This one is the key idea is here is orthogonal basis. If this basis is orthogonal, we're gonna find the linear combination very quickly by using the theorem, guys. So C1 gonna be C1 is YU1 over U1, U1. So you're gonna find it. Y inner product U1. That's gonna be Y inner product U1 is 0 plus 6 plus 4 on the numerator. U1 inner product U1 is 0 square 4 plus 16. That's gonna be 10 over 20. That's the 1 over 2. C2 gonna be Y U2, U2 inner product U2, Y U2. Y U2 gonna be 13 times 5. That's let's do the Y inner product U2 gonna be 13 times 5. That's the 65. 3 times negative 2, negative 6 plus 1. Denominator gonna be 25 plus 4 plus 1. That's gonna be here, that's gonna be 60 over 30, that's the 2. Let's find the C3. So here is, I just make, here is negative 3, guys, okay? Negative 6. So let's find the C3. C3 gonna be y inner product U3 over U3 and U3. So here is negative 39, negative 18 plus 1. Here is 9 plus 36 plus 9. So this gonna be top is numerator negative 54, bottom is 54. This is cancel out negative. Now you find the linear combination of U1, U2, U3 vector. So Y1 equals C1 U1 plus C2 U2 plus C3 U3. That's linear combination U1, U2, U3. C1 is 1.5 U1 vector and plus 2u2 vector minus u3 vector. So you also write down this is vector form, 1.5, u1 vector, u1 vector is 0, 2, 4, u2 vector is 2, u2 vector 5, negative 2 and 1, and the last one is negative, u3 vector is negative 3, 6 and 3.